6. A factory makes silicon chips for use in computers. It is known that about 90% of the chips meet specifications. Every hour, a sample of 18 chips is selected at random for testing, and the number of chips that meet specifications is recorded. What is the approximate mean and standard deviation of the number of chips meeting specifications? Well, this is a case where, and again, you don't always have to write this out, but we should be thinking through, is this binomial? Because then we know where in the formula sheet there are some formulas and stuff like that. In this case, this is binary. Either it meets specifications or not. It is independent. There's no reason to believe that one chip necessarily, and in a problem like this, if they don't give you really any obvious indicator why it wouldn't be independent, then there's no reason to believe that we have issues. So when we actually write out explanations for this, and we're going to get to this when we start doing chapters 8, 9, 10, and so on, what we would actually explain here, to be clear, would be it is reasonable to believe that our selections are independent. Because we can only go off the information we have in the problem. Anyway, fixed number of trials, 18. And the constant probability of success is 90%, so we're good there. So if you go to your formula sheet, if we have a binomial random variable, our mean of that variable and our standard deviation of that variable are right on the formula sheet. The mean is n times p, which here would be 18 times 0.9. And the standard deviation is the square root of n times p times 1 minus p, or n times p times q, which here would be 18 times 0.9 times 0.1, all under that square root. So our mean here would be 16.2. If we crunch out square root of 18 times 0.9 times 0.1, we end up with 1.27. And, well, I guess 273 if you kept rounding, so we are going to go with D. 7. You are stuck at the Vince Lombardi rest stop on the New Jersey Turnpike with a dead battery. To get on the road again, you need to find someone with jumper cables that connect the batteries of 2 cars together so you can start your car again. Suppose that 16% of drivers in New Jersey carry jumper cables in their trunk. You begin to ask people getting out of their cars if they have jumper cables. You're going to give up and call a tow truck if you don't find a jumper cable by the time you've asked 10 people. Assuming our results from person to person are independent, what is the probability you've asked more than 10 people? Well, if we did check these, is it binary? Yes, either they have jumper cables or not. We're told they're independent. We don't have a fixed number of trials. We are counting until first. So check. And the constant probability of success would be our 16%. So we're good to go on our conditions. And again, you don't have to write them out every time automatically, but it's something you should be thinking through. Before you jump into just using formulas, we surely should be thinking through those. Now that we know we have something that's geometric, all we know, we're finding the probability that it takes us more than 10 people, which would mean the only thing we know for sure is that we failed 10 times. Well, the probability of success is 0.16, so I want to take 1 minus to the 10th power, or 0.84 to the 10th power. And that should be 0.1749. Should be B. Okay, so we're the end of our review here is these last 4 all from the same situation. The DMV records show that 5% of cars have expired registration tabs. 8, if you randomly select 20 cars, what is the approximate probability that exactly 2 cars have expired tabs? Well, this is binomial because we have 20, that's success and failure. They have expired tabs or not. We have independent trials. There's no reason to believe it's not. The number of trials is 20, and the probability of success is 0.05. For exactly 2, now this is one on a free response, you would need to show your work. It would technically be 20, choose 2, 0.05 to the second, and then 0.95, or 1 minus 0.05, to the 18th. For us, all we really need to do is a binom p, because we don't have to show work on multiple, you guys do. But even for this, your work is this calculator stuff, because if it was a multiple choice question, you wouldn't have to write out the formula. So we're going to do 20, comma, 0.05, comma, 18. Write that a little bit neater. Not much better, sorry. And so if we type that in under second vars, remember, 20, comma, 0.05. Oh, yeah. No, I wrote it wrong twice. Sorry. The number of successes is 2. I had that 18 in my head from there. But the number of successes here is 2. So the probability of exactly 2 would be a binom PDF 20, comma, 0.05, comma, 2. Sorry about that. Which would be 0.1887. Which would be, well, it'd be closest to 0.19. Nine, if you randomly select 20 cars, what is the approximate probability that between 2 and 6 inclusive? So that means I really want 2 successes, plus 3 successes, plus 4 successes, plus 5 successes, plus 6 successes. So let's think back to that silly little game we played when we did these notes. And in terms of our calculator, I would want to do a binom CDF, 20, comma, 0.05, comma, and I want to add first. So I want to overshoot what I want. I want to get a binom CDF with 6 in there. That technically gives me 0, 1, 2, 3, 4, 5, 6. But then I want to subtract a binom CDF 20, comma, 0.05, comma. Well, if I want to be left with 2, 3, 4, 5, 6, I better not subtract 2 off of here. So the CDF I'm going to use is actually with 1, which would take away just 0 and 1, which would leave me what I wanted. And if we type that in, binom CDF 20, comma, 0.05, comma, 6, don't forget to close the parentheses, then minus a binom CDF 20, comma, 0.05, comma, 1. That leaves me with 0.264, falling off the screen here. Which would be A. 10, in a large sample of 800 cars, what is the expected value? That should set off alarms in your head at this point. We want the mean of that variable, and if it's binomial, it's just n times p, which here is 800, so much larger sample, and 0.05. Well, 800, ugh. I have a nice stylus that writes pretty well compared to most, but sometimes it still is. Or I'm sloppy with it, I guess. Don't blame your tools. 800 times 0.05 would be 40 cars. And last but not least, in a large sample of 800 cars, what is the standard deviation for the number of cars with expired tabs? Well, the standard deviation would be the square root of our sample size times our probability of success, 0.05, times our probability of failure, 0.95. Which would be 6.16, which would be B. So I hope that helps smooth some things out if there were questions that were going rough on there. Otherwise, please feel free to email me or come find me. I'll be in early in the morning. Good luck as you get ready.